Hello everyone, a very warm welcome to this special YouTube live session dedicated to all the hardworking GATE aspirants over there. And my name is Ravi Kumar, and today we are going to discuss some last moment important topics and key concepts and quick revision and some tricky questions and formulas as well. And get ready with the pen and paper. Please stay focused throughout the session. I will try maximum to cover every possible area of the algorithms, algorithm subject for GATE point of view, and be ready with pen and paper and as well as calculator also. So without any further delay, let's start the session. So hope you all ready. Aradhana, Priyanshi, Himanshu, Varun, Priyanka, Kartika, Aman, Siddharth. So good afternoon to everyone. Good afternoon. Let's see the first question. In the topic of asymptotic notations. So write the given functions in asymptotic increasing order. So 1, 2, 3, 4, 5 functions given. All 5 functions are decreasing functions. So all are comes under the decreasing functions only. Write these decreasing functions asymptotic increasing order. Please be ready with the pen and paper and do this question as like a examination. Okay, I'll give some time, probably one to 2 minutes. Please post your comments. And for this question, hint is because these are decrement functions. So compute the ratio of two functions. And after simplification of ratio of two function, if numerator is bigger and f of n asymptotically bigger, if denominator bigger and g of n asymptotically bigger. Whenever two decrement functions, if you want to compute asymptotic value, it is easy thing is compute the ratio of two functions. So based on the numerator, if bigger, then f of n asymptotically bigger, if denominator bigger and g of n asymptotically bigger. So here do not apply logarithmic and all to compute the asymptotic increasing order whenever you are dealing with the decrement functions. Right, Priyadarshini. Priyanka Singh, Hritik Rajan, Yashwant Rai. Here, very good. Okay. So now few functions we can say the asymptotic increasing order, like a 0.4 n is asymptotically smaller than 0.4 n asymptotically smaller than 0.9 0.9 power n. Okay. So now this log n by n is there and c by log n is there and square by 2 power n is there. So this denominator is too big. If you compare n by 2 power n versus log n by n. Okay. So to compare asymptotic growth of these two functions, compute ratio of these two functions. One is log n by n and divide by, so n square by 2 power n. Because both are decrement function, compute the ratio, that is log n divide by, so n cube, and this denominator 2 power n is become multiplication of numerator side. Now numerator is exponential, denominator is polynomial, so that means numerator is bigger. So log n by n asymptotically bigger than n square by 2 power n. That means n square by 2 power n asymptotically smaller. Okay, so then log n by n. Log n by n, then the c by constant by log n is there, constant by log n, and if we compare log n by n square by 2 power n, so f of n is assume that c by log n, constant by log n, and g of n is, so g of n is if we compare with log n by n, then this is becomes c multiplied with n log n whole square. Now numerator is polynomial, denominator is logarithmic, numerator is asymptotically bigger, so constant by log n is also bigger than, so constant by log n also bigger than log n by so constant by log n is the bigger function than n by log n by n. So these three functions are concluded. Now 0.4 power n. So if we compute the ratio of f of n by g of n, okay, so the denominator it is 4 power n by 10 power n, denominator is exponential, so compare with this smaller function. So this is n square by 2 power n, so it is becomes 4 power n multiplied with 2 power n divide 10 power n multiplied with n square. So this is numerator if you take this is one part, so 4 into 2 8 by 10 0.8 power n divide by n square. Numerator decreasing and denominator polynomial, so denominator is bigger, means n square by 2 power n is greater. So compared to this 0.4 power n is asymptotically smaller. Then one more function is there, 0.9 power n, it is always bigger than 0.4 power n only. Then compare with these two, compare with this one. So f of n by g of n ratio if you calculate, f of n by g of n ratio if you calculate, 0.9 power n can be written as 9 power n by 10 power n, denominator is n square by 2 power n. So this is 9 to the 18 by 10, okay, so 1.8 power n divide by, okay, n square. So exponential and polynomial, so that means numerator is bigger, so 0.9 power n is bigger than this one. So and again compare with this n by log n by n. So if you calculate f of n by g of n ratio, so f of n is 9 power n by 10 power n and g of n is log n by n, log n divided by n. Compute the ratio, 9 power n by 10 power n, okay, that means it is 0.9 power n, okay. So denominator side is multiply with n is there, so denominator is log n, okay. So if you convert this into the denominator side, so it becomes 10 by 9. So 10 by 9 means denominator become exponential. If you convert this into denominator side, denominator become exponential. This is become 10 by 9 whole power n, okay, multiply with log n. So denominator exponential, numerator polynomial, the log n by n is greater. That means 0.9 power n is greater than this and smaller than this. This is the asymptotic increasing order. Answer to this question is, I think, option B. Right? Yes, almost all are given correct answer. So, whenever you are comparing asymptotic growth rate for two decrement function, compute the ratio. So, based on the given function, see, sometime we may apply limits, sometime we may apply logarithmics, sometime okay, we may compute the ratio between two functions. So, based on the given two function, you need to understand what you need to apply, right. So, n equal to 1, the substituting n equal to 1, that is not going to be work for asymptotic growth rate. Okay. See here already function is decrement function. If you apply logarithmic, it is become negative na. So, what is log value of log n by n? Okay, log n minus log n. Okay, it's become negative function. Asymptotic growth is not possible to apply for negative functions na. So, whenever decrement function, you need to deal like this. Okay. So, if not decrement function, sometime you can apply logarithmic also, right. Yeah, whenever we compare two decrement function, compute the ratio. This is the one fundamental thing, right. So, I hope you cleared this one. Almost all doubts I cleared, which are given in the chat box. Okay. Then one more question also from the asymptotic notation, and now here you can apply the logarithmics. Here you can apply logarithmic and test the asymptotic increasing order. Okay. So, taking some value is always try to ignore. Okay. So, because asymptotic comparison does not mean that value comparing with the small n values. For small n value, one function is bigger than other function. It need not be the same thing happen for the large n value. Okay. So, try to avoid the get the conclusion of asymptotic comparison by substituting the n values. That is not a correct idea. Right, Ritik. Then this one, is it everything visible, question and all? Here Raksha, okay, everyone answered, yes, correct. Okay, all are given correct answer. Here you can apply the logarithmic. Okay, so already we know these three functions asymptotic increasing order is known to you, because base is same, power is smaller, means asymptotically smaller. Okay, so 2 power n by 2 2 power n by 2 asymptotically smaller than 2 power n asymptotically smaller than 2 power 2n, and if you apply logarithmic to this 2 power 2n, it is n multiplied with log 2, and if you apply logarithmic to this n factorial, log n factorial is n log n. Okay, so log n factorial is n log n. So that means if log 2 power 2n is becomes 2n multiplied with log 2. Okay, so this log n factorial bigger than log 2 power 2n, that means so the n factorial asymptotically bigger than 2 power 2n. Okay. Now, so compared to n factorial, these two functions asymptotically bigger. Okay, because if you apply logarithmic to this, it becomes 2 multiplied with 2 power log 2 power n, it is becomes n square multiplied with 2 power n square multiplied with log 2. So log of these two functions is bigger than, okay, so log n factorial. So that means these two are bigger functions. to get the asymptotic comparison for these two functions 2 power n whole square and 2 power n square. Okay, apply logarithmic to these two functions. So it is 2 multiplied with log 2 power n. Okay, 2 multiplied with log 2 power n, it is becomes n multiplied with 2 multiplied with log 2. Okay, so this is asymptotically smaller than log n factorial also. Okay, log n factorial is asymptotically greater. Yes, okay. So this is asymptotically n factorial asymptotically greater than. So n factorial asymptotically greater than. So what is this function 2 power n whole square? Because if you apply logarithmic to this one, it is become n multiplied with constant. If you apply logarithmic to the log n factorial, it becomes n log n. Okay, so it is bigger than this. Okay, so these two are asymptotically equal. Okay, 2 power n multiplied with 2 power n. So these two are asymptotically equal. Okay, so asymptotic equal functions. Then this is asymptotically bigger. Okay, in case by mistake options not matches, then it's fine. It's asymptotic increasing order. So so 2 power n by 2 less than 2 power n less than 2 power 2n. Okay, so the option A is more suitable. Okay, for the asymptotic increasing order. Okay, so but it should be asymptotically equal here. Right. So this is the asymptotic increasing order for this given functions. So let's see one more question related to the asymptotic notations. Okay, it's one interesting question. Do this one MSQ question. Which of the given statements is or true? Is or correct? If f of n is big O of g of n, then 2 power f of n is also big O of 2 power g of n. F of n little o of g of n, then 2 power f of n also little o of 2 power g of n. 2 power f of n is big O of 2 power g of n, then f of n also big O of g of n. 2 power f of n little o of 2 power g of n, then f of n also little o of g of n. Try this question. Two power n and n factorial. Okay, see for the previous question, so some are asking between 2 power n and factorial. So 2 power n and n factorial, if you apply logarithmic, okay, it is becomes log 2 power n. Log 2 power n means it is becomes n log 2, right? Okay, n multiplied with log 2, and this one is log n factorial. Log n factorial is becomes n log n. So log g of n is greater than log f of n, and hence we can say that so 2 power n is asymptotically smaller than n factorial. How to solve in easy way? So apply logarithmic. So based on the function you need to do. Okay, sometime we may apply ratio of two function, or sometime we may apply logarithmic, and sometime we may apply so limit n tends to infinite f of n by g of n, the limits and all. So depends on the function, we need to see what methods should be applied, so that we can apply we can able to conclude asymptotic order, right. It is MSQ question. So A, B, D, A, B, C, only D. So different answers. Okay. So just take some time, some 30-40 seconds, do some calculations, and please try to give the correct answer. Do some calculations and verify. Take some example functions and all. Okay. So I will explain one option, meanwhile you try the other options also. So f of n big O of g of n, f of n big O of g of n means that f of n can be asymptotically smaller or equal to the g of n. F of n can be asymptotically equal also or asymptotically smaller also. Okay, then 2 power f of n is also asymptotically smaller or equal to 2 power g of n is true or false. Okay, see, this statement is true if f of n asymptotically smaller than g of n. F of n asymptotically smaller than g of n, 2 power f of n asymptotically smaller than 2 power g of n. But in case f of n g of n asymptotically equal, so where f of n constant time bigger, assume f of n is some 2n and g of n is n. So that means, see, 2n asymptotically smaller or equal to n is true. Okay, constant multiplication is neglected, but that constant in power side is not neglected. Na? So if you go for 2 power 2n is not asymptotically less than equal to 2 power n. So that means if f of n constant time bigger than the g of n, if f of n constant time bigger than the g of n, so this asymptotic comparison of f of n less than equal to g of n is true, but 2 power 2n is not asymptotically less than equal to 2 power n. So in such cases the function, the first statement is false. Then second statement, f of n is little o of g of n. Little o of g of n means f of n is asymptotically smaller than g of n. If f of n asymptotically smaller than g of n, guaranteed 2 power f of n also asymptotically smaller than 2 power g of n. Okay. So already f of n already asymptotically smaller than g of n, assume that n asymptotically smaller than n square, then f of n is n and g of n is n square, then 2 power n also asymptotically smaller than 2 power n square. Okay. So the second statement is true. Then third statement, 2 power f of n less than equal to 2 power g of n. Okay. So 2 power f of n big O of 2 power g of n means less than equal to 2 power g of n. See, f of n and g of n in the power side, to become asymptotic equal, f of n g of n should be exactly same. Okay, then in that case f of n also asymptotically less than or equal to g of n. Okay, there are two possibilities for this function. F of n g of n should be exactly same, assume f of n and g of n is n. So 2 power n less than equal to 2 power n, then the f of n is n and g of n is n. So n is also less than equal to n, asymptotic equality is true. And other possibility, 2 power f of n asymptotically smaller than 2 power g of n means f of n should be asymptotically smaller than g of n. That means assume that 2 power n asymptotically smaller than 2 power n square. In that case also n asymptotically smaller than n square. Okay. So this statement is true, and this is also true statement, that is applied for this one. Okay. Second case, if you remove the equality, then also still the statement is true. So B, C, D is the correct answers, correct statements for the above question. Right? So each question consists multiple concepts. Okay, this question consists so many concepts. Okay, so such a complex question means it is equivalent to solving 4-5 questions. That's such a way I framed the questions. Even if one or two mistakes, one or two option mistakes, don't get demotivate. Okay, so I added multiple concepts in the same question. How option D is true? See, 2 power f of n asymptotically smaller than 2 power g of n, small o. Okay, so 2 power f of n asymptotically smaller than 2 power g of n. So 2 power f of n, okay, is asymptotically smaller, little o, 2 power g of n. So to satisfy this condition, okay, f of n must be asymptotically smaller than g of n. F of n must be asymptotically smaller than, okay. So 2 power f of n, so wait for this one. So 2 power f of n, little o of 2 power g of n. So 2 power n and asymptotically smaller than 2 power 2n. Okay, so then n asymptotically smaller than 2n is false, right? So option D is also false statement. So sorry for this overlook, I didn't tested this one. So option D is also false for this one. So correct answer is only BC. Right. Right. Correct answer is only BC. Okay. So let's move one more simple question. It is, I think you can able to answer this easily. Okay. Which of the following statements is or true? Which of the following statements is or true? So hint of this question, based on these statements, based on these given statements, first write asymptotic increasing order for f, g, h. F of n, g of n, h of n. These three functions write asymptotic increasing order. Once you write asymptotic increasing order for f, g, h, then you can able to understand which option is correct. First write the asymptotic increasing order for the given three functions f, g, h. Srijit, very good. Sayan Chowdhury. Srijit, Rajkesh Jain, Hia, Sayan Priyanka, Swapil Swaroop. So all are given almost correct answer. Let's see this one. Okay, f of n according to the first statement. f of n asymptotically less than or equal to g of n. Okay, so g of n not based on these two conditions, f of n big O of g of n not big O of f of n. So based on these two conditions, f of n asymptotically smaller than g of n. Based on these two statements, f of n asymptotically smaller than g of n. G of n big O of h of n big O of g of n. Because of these two statements, so g of n h of n asymptotically equal. G of n asymptotically equal to h of n. So f of n asymptotically smaller than g of n. So f of n asymptotically smaller than g of n, and g of n asymptotically equal to h of n. So these are the three given functions. So based on these three given functions, see which option is correct. So f of n also asymptotically less than h of n, f of n is big O of h of n is true. Okay, f of n also less than h of n. So h of n not big O of f of n, h of n not big O of f of n is also true. Okay, so h of n, because so the f of n is asymptotically smaller than h of n, f of n is asymptotically smaller than h of n. So f of n is asymptotically smaller than h of n, so h of n is not big O of f of n. Okay, then f plus h. So if you take f plus h, the maximum term is h of n, leading term is h of n. Okay, and g plus h is also maximum term is h of n. Okay, so that means f plus h, f of n plus h of n, okay, and g of n plus h of n, g of n plus h of n are asymptotically equal. These are asymptotically equal. Because of asymptotic equal representation, big O is also true, big omega also true, theta also true. Okay, asymptotic equality is there between these two. Okay, so big O of this is also true. So this option B is also true. So f plus g not big O of g plus h. See, g and h both are asymptotically equal. G and h both are asymptotically equal. G and h can get cancelled. G and h can cancel, common terms, common factors. Then f of n not big O of g of n. F of n not big O of g of n is false. F of n big O of g of n is true. Okay, that means option D is false statement. So the answer to this question is ABC. Right? Yes, everyone given correct answer. I think it's not required much explanation. Please post your comment if at all any explanation required to any of these cases. First write asymptotic increasing order, then you can able to find correct answer. Sir, we can write f of n constant into g of n. Yes, f of n constant in, no, f of n not constant into g of n, not asymptotically equal, because he two not only f of n big O of g of n, g of n not big O of f of n, g of n not big O of f of n. So because of the second statement, asymptotic equality ruled out here. Okay, here asymptotic equality ruled out here, because g of n not big O of f of n. F of n big O of g of n means less than or equal, but because g of n not big O of f of n, this equality not occur now. Asymptotic equal possibility is not there. Okay, yeah, so DGS, right? So the overall, if it is only f of n big O of g of n, might return f of n less than equal to g of n, but g of n not big O of f of n. So because of overall conclusion of these two conditions, is f of n asymptotically smaller than g of n, right? So option D, see, g and h asymptotically equal, g and h asymptotically equal. So that means if g of n square, h of n also n square, the n square common factor if you remove, then what he is saying that f of n not big O of g of n is false na, because f of n is asymptotically smaller than g of n, f of n asymptotically smaller than g of n, f of n not big O of g of n is false. Okay. Yeah, f of n small o of g of n, you can write f of n small o of g of n, that is also a correct statement, okay, but not given in the options na. F of n is small o of g of n. Anushka Srivastava, clear. Okay, if you have any doubt on this question, just post your comment. Meanwhile, I will display the next question. It is one of the recursive algorithm. It is one of the recursive algorithm. So recursive of n, if n less than equal to 4, return 1. Okay, else return 2 times recursive of 4th root of n plus 2 times recursive of 4th root of n plus log n multiplied with log n. Assume computational cost of this log n multiplied with log n is constant. Okay, so computational cost to compute log n multiplied with log n, this computing cost of this, assume constant time. Okay, constant time to compute this, constant time to compute log n multiplied with, okay, to compute, okay, log n multiplied with log n value, okay, is the assumption. Now what is time complexity and what is return value? Swaroop, because f is less than, for previous question he is asking doubt, okay, how this maximum how it is become maximum for these two summation, for these two summation f plus h, okay, for f plus h, okay, h of n is maximum because f of n also less than h of n, f of n asymptotically less than h of n, so f and h added, the asymptotic bigger value is h of n only, that is why h of n is maximum than maximum in this summation. Okay, in this summation also h of n is maximum, of course both are equal. So because of both are asymptotically equal, both are f of n square, n plus n square asymptotically equal to n square only, n square plus n square asymptotically equal to n square only. So in this way f plus h as well as g plus h are become asymptotically equal, these two summations are become asymptotically equal. If asymptotically equal means big O, omega, theta all are true, right. So, question number 5 MSQ question. Write the recurrence relation. Okay, a recurrence relation for asymptotic, sorry, a recurrence relation for time complexity recurrence relation. So, assume that T of n time required for a recursive of n. Okay, so time complexity of a recursive of n, let us say T of n. Okay, so time complexity of the time complexity recursion. See, one subrecursion of 4th root of n, one more subrecursion of 4th root of n, and this remaining computational cost multiplying this 2 and multiplying this 2 and computing this log n plus log n, log n multiply with log n. So, this remaining cost is constant. That means 2 subrecursions. Okay, so 2 subrecursions, each subrecursion, okay, 4th root of n time, and remaining cost is constant. I am just using 1. Okay, excess cost is constant. Okay, so this excess cost is constant. Constant time other than subrecursions. So, other than subrecursions, this is the time complexity recurrence relation, and you can use change of variable concept. Okay, so I think you all to apply master theorem, apply the change of variable concept. Okay, I am not going in detail the procedure of change of variable. So, n is, okay, assume that n is 4 power m, assume n equal to 4 power m for change of variable concept. So, it becomes T of 4 power m is becomes 2 times T of 4 power m by 4, 4 power m by 4 plus constant, and T of 4 power m assume that S of m. So, it is becomes 2 times S of m by 4, 2 times S of m by 4 plus constant. Okay, so here master theorem, the m to the power of log a base b is root m. Master theorem case 2 is applicable. Okay, master theorem case 2 is applicable. Okay, so this is equal to, so it is square root of m log 2 base 4. Okay, square root of m. So, n equal to 4 power m. So, m is log n base 4. It means that the T of n solution, T of n solution is theta of square root of, okay, n equal to 4 power m means m is log n base 4. Okay, square root of log n. Okay, is the time complexity of the recursion. This is time complexity of the recursion. So, square root of log n, theta of square root of log n. So, the time complexity log n multiplied with log n is also false. Log n multiplied with log n whole square is also not true. Okay, both are wrong options. Time complexity not matches. Okay. Next, the return value of the recursion. T of n, assume that return value of the recursive of n. Okay, so recursion for the return value. So, while computing return value, we need to compute this complete part. Complete value is calculated. So, 2 multiplication, as this 2 multiplication, total it become 4 multiplication of recursive of 4th root of n plus this value added before returning, this also considered as it is. That means it becomes 4t of 4th root of n, 4t of 4th root of n plus okay, log n multiplied with log n multiplied with log n. Okay, now apply change of variable concept. Again assume n equal to 4 power m. N equal to 4 power m means it becomes t of 4 power m equal to 4 times t of 4 power m by 4, okay, plus, okay, so this, yeah, log 4 power m, it become m multiplied with log m, okay, log n equal to m. So then t of 4 power m is changed to s of m, it becomes 4 times t of, okay, 4 times s of m by 4, okay, plus m multiplied with log m. Now apply master theorem here. So master theorem, case 2 is applicable. Case 2 is applicable for this case is applicable for master theorem. So if f of n is asymptotically equal to n to the power of log a base b multiplied with log n power k, so this case is applicable. Okay, so modification of this case 2. Okay, for k equal to 1 this condition is true. So then t of n equal to the theta of m multiplied with, okay, for k1 true means t of n become k plus 1, that means it become log m whole square, then change m to n, it is becomes, so m is log n base 4, okay, log n multiplied with log n whole square. Right. So is the return value, so log n multiplied with log n whole square. So option C is only correct statement. Only option C is correct statement, because time complexity is root log n. Root log n is not there in any of the options. Right. So post your doubts. So here two things you need to understand here: how to convert a recursion time complexity recurrence equation. For this algorithm, how to convert return value recurrence equation. So once we convert recurrence equation for the recursive algorithm for both time complexity and return value, then this kind of recursion can apply master theorem by using the change of variable concept. So changing variable n to 4 power m and t of 4 power m changes to s of m, then it becomes master theorem form, then apply master theorem and convert back to m to n. Okay. So here Raksha Singh, log n equal to 2m. So n equal to 4 power m, means m is log n base 4, Okay. So this kind of recurrence equation, solving recurrence equations is almost from last 3-4 years. Okay, every year 1-2 mark question is used to ask. So I will show you last 5-6 years what are the different topics they ask in the examination according to the GATE exam. I will show you at the end of the session. Last 5-6 years what are different topics they asks. Okay, so that you will understand what are more frequent areas which are given from in the last 4-5 years. Okay, right? Any doubt on this? So, and solve this question. Two alternative packages A and B are available for processing database having 10 power k records. Okay, 10 power k records are there, means input is 10 power k records. Package A required 0.00001 multiply with n square time. Okay, this much time to process by package A, and package B time is 100 multiply with n log n base 10. Package B 100 multiply with n log n base 10. Okay, so time units for process and records. So what is the smallest value of k? What is the smallest value of k for which package B will be preferred over package A? Means package B should be less time, less cost than package A. Okay, so what is the smallest, what is the smallest k value such that package B is better than the package A? For DA algorithm as it is, except the all these are common for DA also. So okay, so some are asking so about the DA topics. So DA is also the same concepts, okay, except the dynamic programming and some greedy techniques are not required, and other than that, so more or less the DA and CS is almost same algo syllabus. Okay, so even though they didn't mention few topics in the DA, but last year they asked about the notations also, recurrence equations also, and recurrence relation, time complexity also. Okay, so all fundamentals is required for DA as well. For GA, how many students can appear? Okay, expected probably 50-60,000, 50 to 60, because most of the CS students is also applying for DA. So probably around 50 to 60,000 students can appear for GATE DA. I am expecting that much. Very good. Okay. So now, so package A for n input size, okay, for n input, okay, package A and package B. So package A is 0.00001, 1 2 3 4 5 digits na, that means n square by 10 power 5 is the processing time for an input. Package B is 100 multiplied with 100 is 10 square, 10 square multiplied with n log n base 10, n log n base 10, okay, is the package A and package B. So this type of question has to be take some small n value substitution only, okay, because not asymptotic comparison here. So we can use the substitution method for this question. For example, if you take the n equal to 5, okay, so 10 power 5 it means to say it in terms of 10 power k na, so n equal to 10 power 5, okay. So 10 power 5 whole square is become 10 power 10 divided by 10 power 5 is overall become 10 power 5, and this is becomes, okay, 10 square multiplied with 10 power 5 is 10 power 7 multiplied with log 10 power 5 base 10 is 7. So still the package B is more cost, still the package B is more cost, Okay, that means the n value should be more than 10 power 5. So if you take n equal to 10 power 6, n is 10 power 6, 10 power 6 whole square, 10 power 6 whole square is 10 power 12 by 10 power 5 is 10 power 7. Okay, so 10 square multiplied with 10 power 6 is 10 power 8. Okay, so 10 square multiplied with 10 power 6, 10 power 8, log 10 power 7 base 10 is 7. Still package B is more cost. Okay, so if you still increase the n value, if you take 10 power 7, 10 power 7 whole square, 10 power 14 by 10 power 5 is 10 power 9. This is 10 square multiplied with 10 power 7 is 10 power 9, multiply with log 10 power 9 base 10 is 9. So still 9 times bigger than this. Still package B is more cost. So still if you take the next 10 value, 10 power 8. Okay, 10 power 8 whole square, 10 power 16 by 10 power 5 is become 10 power 11. Okay, so 10 square multiply with 10 power 8 is 10 power 10, multiply with 10. Okay, so 10 square multiply with 10 power 8, 10 power 10 multiply with 10. Now for this it is equal cost, for this it is equal cost, for the next n value it is become bigger cost. Okay, so smallest n is 10 power 8, for k value is 8. Okay, for k value 8, okay, package B can be preferred. Now both packages are equal only, so even if you take the next value, the second package becomes smaller. Okay, smaller or equal, you can prefer the package B. Okay, because he is asking smallest value where we can prefer the second package than the first package. So k value is 8. Answer to this question is 8. Sayan saying that similar to one of the PYQ question. Yes, okay, it is similar to the one of the PYQ question. Right? Is this cleared? Okay, so those many times you done PYQ. Okay, so it is nice to see that PYQ question answer also without having question. Okay, how many students appear for GATE CS? So last year is around 1,20,000 something. Okay, so it may be 10-20,000 more than last year, probably 1.5. Yeah, for 10 power 9, 10 power 9 B cost is become, now if you take n equal to 10 power 9, that B cost is become smaller. Even for equal also we can prefer the B, na? Even for equal also we can choose B rather than A. The smallest k value is 8, greater than equal to 8, it mean to say. Okay, for equal package A and package B both are okay, but we can choose package B also even for equal cost. Even for equal cost we can choose package B as well, right? Right. Smallest B is k equal to 8. Now similar to this question, previous question, okay, assume that we are given two algorithms, A1 one algorithm, A2 one algorithm for input size n. Algorithm A1 takes order of n time, theta of n time. Algorithm A1 takes theta of n time. Algorithm A2 is theta of n square time, theta of n square time. For n equal to 16 input, for n equal to 16 input, algorithm A1 takes 48 seconds, algorithm A2 takes 512 seconds. Okay, so T of A1 and T of A2 cost is given. Now for n equal to 64 input, what n equal to 64 input, what is difference between, okay, cost of second algorithm minus first algorithm? Okay, what the difference for n equal to 64 input? So more interesting means a more important graph questions and other one by one topic we go. So first we are fundamental questions, we are discussing notations and basic fundamental questions and recursions. Okay, so after that next graph questions and spanning tree questions as well as, okay, the traversal questions and means a more important questions set to be discussed. Very good. Swapil here. Very good. Okay, see this kind of question, see the time complexity of A1 is one algorithm. So time complexity of A1 is theta of n. So write the time complexity like this, time complexity of, okay, first algorithm. So time complexity of this first algorithm is constant time multiply with n, theta of n. Theta of n is written as constant time n. Okay, so many times this model questions is given, all question format is same. Okay, so they give the time complexity in the question and they also give for one input how much time it taken. So from that you will get the constant. Okay, so that means if n equal to 16 input size, okay, 16 input size, the A1 takes 48 seconds. That means 48 seconds, okay, for n value 16, so that C is equal to 48 by 16, okay, equal to 3, right? Okay, then time complexity of the first algorithm, C is 3 na, 3 multiply with n, okay, is the time complexity for first algorithm. Okay, if this is the time complexity for first algorithm, so input size 64, that means T of 64 cost, 3 multiplied with 64, is the cost of the first algorithm. Now similarly take the second algorithm A2. For A2 algorithm time complexity given n square. So T of n is constant time n square, and already for n equal to 16 that 512 seconds required, 512 seconds for n equal to 16. Okay, so 512 seconds time, T of n is 512, for the input is 16, C multiplied with 16 square, n square, then C equal to, okay, so 512 means 2 power 9 divided by 2 power 4 whole square, so 2 power 8, so 16 square, I think it is 2, right? So 2 power 9 by 2 power 8, 2. So that means the second algorithm time complexity is 2 times n square, is the time complexity of the second algorithm. Then what the time required for 64 input? Okay, T of 64, for 64 input 2 multiplied with, okay, 64 whole square. Okay, then difference between these two. Okay, so the second algorithm 2 multiplied with 64 whole square, cost for 64 input, minus First algorithm 3 multiplied with 64. Okay, do the calculation. So the answer to this question is 8,000. 8,000 seconds difference. Okay, DSG. Right. So this model question is around 7 to 8 times given. All are almost format is same. Okay, so they give the time complexity, use the constant multiplication, and they give one input and one cost, and based on that constant you will get, and so then you will get the accurate value of the time complexity expression and substitute the n value for whatever he is asking. Okay, the same format for any of this model question. Now next one. Now so try this question. What would be the worst case complexity of insertion sort? Okay, it is a known question only. Uh, just to recollect one important point related to the insertion sort and bubble sort, I gave this question. It is simple question and known question to you. Okay, so just recollect it. So one important concept related to the insertion sort and bubble sort. So DGS, Tarun, Hia, Raj Zain, very good. Okay, so for insertion sort, write as a note. For insertion sort and for bubble sort. Okay, number of swaps and number of comparisons. Okay, so insertion sort and bubble sort, number of swaps and number of comparisons. Okay, number of swaps for the insertion sort, okay, is exactly equal to number of inverses of the array. Number of inverses, okay, of n elements. Assume that input is array of n elements. Okay, number of insertions are number of inverses. For even for bubble sort also, number of swaps are number of inverses only. Okay, both are same, but comparisons of the insertion sort, number of comparisons are, okay, number of inverses, okay, maybe one extra comparison for each pass, one extra n minus 1 comparisons extra. Okay, except in the worst case. Okay, so except worst case. Okay, in worst case, number of comparisons are number of inverses. Number of comparisons are number of inverses in worst case. Okay, it means which is n into n minus 1 by 2 comparisons and inverses. But bubble sort, even if inverses are equal to the number of swaps, bubble sort swaps are equal to the inverses, but comparisons are may not reduces. Okay, even less inverses, comparisons may not reduces. So it may takes n into n minus 1 by 2 comparisons. Okay, n into n minus 1 by 2 comparisons except best case. Okay, except best case. Okay, so bubble sort, the array has less number of inverses. If array less number of inverses, okay, so then time complexity of insertion sort guaranteed less only reduces, but time complexity of bubble sort may not reduces. Time complexity of bubble sort may not reduces. So because the except best case comparisons of bubble sort is n into n minus 1 by 2. Okay, even less inverses. Okay, if n inverses only in the array, so n swaps only required and n comparisons plus n minus 1 comparisons, overall it become order of n only. Overall it become order of n only. If n inverses only exist, then n swaps required for bubble sort, but comparisons not reduces. That is why bubble sort time complexity is not reduces, right. Right. All sorting algorithms, comparison table. Best case n minus 1 comparisons, n minus 1 comparisons in best case, one pass, n minus 1 comparisons in best case means just one pass. Okay. So yeah, sometime in FSTs, some FST you may get the less marks, some FST you may get the more marks. Okay, so probably one FST may have more difficult questions. Okay, or more means FST we distribute in all topics, right? FST 1 to FST 8. So means not all the FSTs considered the same topics, right? Okay, so in this way, sometime FST you may get the less marks, sometime you may get the more marks. No need to demotivate. Okay, give the FSTs. Okay, like MEDIZ provides 4 basic full syllabus tests, 4 advanced full syllabus tests, and 4 mock tests, and 1 computer based test CBT. Okay, so give all the 13 full syllabus tests. Okay, it is more than sufficient. So sometime FST may get the less marks. Okay, so that is common thing, not only for you, Mantos Kumar. Okay, not only for you, any other also. Okay, if sometime FST may get little less marks and sometime you may get more marks, don't worry about it, right. So hope you cleared this one. Just note down this one. The for array of n elements, number of swaps of insertion sort and bubble sort exactly equal to number of inverses, but comparisons of the bubble sort is not reduces. That is the reason. Even if less inverses, bubble sort may takes the more time. Okay. Right. Next question. So 4 statements given in this question. So algorithm A works with 2 subarrays and algorithm B works is a special case of algorithm A. Okay, that means algorithm A is fully divide and conquer algorithm. Algorithm A is fully divide and conquer algorithm, and algorithm B is special case of algorithm A. Okay, which one of the sub array, okay, so single element, which of the following may be considered as, okay, A comma B is pair. Okay, that means B should be special case of A. B should be special case of A. Okay, so merge sort, insertion sort, merge sort, selection sort, quick sort, insertion sort, quick sort, selection sort, and merge sort, bubble sort. Right. Gyanendra, all are saying B. Raksha Singh, Nilok, Priyanka Singh, right. So, see, merge sort, divide the list into 2 equal subproblems and okay, merges. Okay, so whereas insertion sort is a special case of merge sort. Insertion sort is a special case of merge sort, something like this one. So first list 1 element and second list 1 element. So insert, okay, merge into 2 elements, okay, and 2 elements in the one list and 1 element in second list. Okay, first element and second element. These 2 elements in sorted order. 2 elements in one subproblem, okay, and 1 element in the second subproblem. 1 element in the second subproblem, and these 2 are merges. These 2 are merges. It becomes sorted array of 3 elements. Okay, sorted array of 3 elements, and 3 elements in one subproblem, and so 1 element in other subproblem. If you merge, then it becomes sorted array of 4 elements. Okay, these 4 elements in sorted order. Okay, if you observe this scenario is the insertion sort. This scenario is insertion sort. Okay, where second subproblem is always 1 element. The second subproblem is always 1 element. In other words, okay, so not optimal merging. Okay, if optimal merging means 2 equal parts, divide into 2 equal parts, 2 1 element, 2 elements, 4 elements merges. Okay, not optimal. Okay, so in this way it is merges. Okay, so the insertion sort is a special case of merge sort, where the second sorted subproblem 1 element, and merge sort is more efficient merging. Okay, non-efficient merging is applied for insertion sort. So this is one pair. Okay, then obviously merge sort and selection sort is not similar. Okay, quick sort and insertion sort also not similar, and quick sort and selection sort is a special case. So for example, if you implement quick sort with pivot element is minimum element, okay, choose minimum element as a pivot element. Okay, quicksort with pivot element is minimum element, okay, is equal to selection sort. This is equal to the selection sort. Okay. So merge sort and bubble sort is not same. Okay, merge sort is merges, bubble sort is apply, compare and exchange adjacent elements. Okay, that is not the procedure of the merge sort. So 1 and 4 na 1 and 4. Answer to this question is option B. Right. So next question, consider array of 10 elements. Okay, so 1 minute, small easy question only, do it fast. Okay, so consider array of 10 elements, 10 elements array is given. Okay, so which of these statements are correct? So in order to sort array in ascending order, which is correct statement? Number of swaps using insertion sort is 20, number of swaps using bubble sort is 20, and number of swaps using selection sort is 45, and number of comparisons using selection sort is 45. Right. So the number of swaps of the insertion sort. See, just before we discussed, so number of swaps of insertion sort and bubble sort, is total number of inverses of the array. Number of inverses of the array is the number of swaps. Okay, for both bubble sort and insertion sort. Okay, so just compute the number of inverses of the array. Okay, So number of inverses of the array, inverses of this array, okay, element 40, okay, so 40 and 30 inverse, 40 and 20 inverse, 40 and 5 inverse, 40 and 10 inverse and 25 inverse. So for 40, 1, 2, 3, 4, 5, 5 inverses for the 40. The next element is 80, okay, second element, assume these are array indexes, a of 1, a of 2, 3, 4, 5, 6, 7, 8, 9, 10. So the is the array indexes, assume that, okay. For 80, 1, 2, 3, 4, 5, 6, 7, 7 elements are smaller than 80, okay, after a of 2 position. So 7 inverses, okay, for the 80. So for 30, 3 inverses, 3 elements are smaller than 30, okay, 3 inverses, okay, 3 only na. So 20, 3, 4 inverses including 25. So total 4 inverses for the element 30. For 20, 2 inverses, 2 inverses for the element 20, okay. For 5 no inverse, okay. For 10 also no inverses, okay. For 25 also no inverses, okay, right. So for 90 2 inverses are there, so for 90 2 inverses are there, for 65 no inverses. These are the total inverses, 12 plus, okay, 4 16, so 18 20, total 20 inverses. 20 inverses means by using insertion sort, by using insertion sort, by using bubble sort, exactly 20 swaps only required, both are correct statements. The number of swaps by using selection sort is 45 is wrong statement. So selection sort number of swaps is always n minus 1, okay. So only n minus 1 swaps, n minus 1 swaps, okay, using selection sort, using selection sort, okay. So 45 not required. Number of comparisons using selection sort, okay. So the number of comparisons for selection sort, number of comparisons for selection sort is n into n minus 1 by 2 all cases, no matter what the input, no matter what the input, all cases n into n minus 1 by 2 comparisons, that means 10 multiplied with 9 divided by 2 is 45, 45 comparisons required for the selection sort is also true statement. So answer to this question is ABD, right. Yeah, almost here. DGS Guru, okay, I'll go. All are given correct answer. Yeah. So one question they are asking, one question they are asking, okay, about the 2025 DA question, okay, in 2025 24 2024 DA question. So I think some 60 70 80 90 some 5 elements are given, okay, 60 70 80 90 100 or whatever the elements, 5 elements are given, it's already in the sorted order. So if you go for quick sort and first element is a pivot, okay, quick sort and first element is a pivot, how many swaps required, okay, quick sort with first element is pivot, okay, so how many swaps required, so number of swaps, okay. See, if 60 is already in correct position, okay, so no see 60 is already smaller than the remaining elements, so only one swap required for each partition P. See, before placing 60 in correct position, what is pivot algorithm, okay, so partition algorithm, in partition algorithm, okay, so this A of j places in correct position and A of low to mid minus 1 should be less than equal to A of j, and A of j plus 1 2, so A of n is greater than equal to A of j. So such a way the one pivot element places in correct position. So after to place pivot element in correct position, so smaller element shifted one side, bigger element shifted other side, and the one more swap required between the pivot element with A of j. Okay, one more swap required between pivot element with A of j. So that minimum one swap required for pass 1. Okay, that means 60 swaps with itself only. Then second pass 70 swaps with itself only. Third pass 80 swaps with itself only. Fourth pass 90 swaps with itself only, and after that only one element, not called the partition called only more than one element. So in this way we can consider that 4 swaps required. But however, this is the question, answer to the question is 4 not 0, okay, according to the official key, but it is depends on the partition code also. Okay, it depends on partition code also. If you change little bit, like if pivot element and A of j is the same position, no, okay, no, not required to swap, means one extra condition if we include, it may become 0 swaps. Okay, so but so if you don't consider as a special case, if you don't consider as a special case, each partition is required minimum one swap. Each partition required minimum one swap. Okay, so answer to this question is 4 n minus 1. Okay, so next one, do this question. See, algorithm performs, this model question also repeatedly used to ask. Okay, so many times given in the exam also. Algorithm required to perform n insertions, elements should be insert one after other. Elements should be insert one after other. Then n key decrements, okay, n key decrements, and pointer given where to decrease the key. Pointer given where to decrease the key. N delete max operations, so n delete min operations. Okay, so these are the three things are required to do by the algorithm. Then which is best data structure for this one? Unsorted array, min heap, sorted array, sorted double linked list. Which is best algorithm? Just recollect it. So it is one of the known model question only, not a new format of the question, but it's a frequently used in examination. So almost every 1-2 years one question of this format is used to ask in the exam. Okay, so right. So here TGS, Guru, Shayan, Rajik, all are saying option A. Just rethink again. see this one, how much cost? See, insertion should insert the keys one after other. Okay, that is the assumption. Otherwise, the two options give the same time complexity if we don't insert the keys one after other. Okay, if you go for unsorted array, one insertion is constant time, repeated n insertions. Okay, delete mean we need to find minimum. Find minimum required order of n time because it's unsorted array. So the repeated n times become n square time complexity. So key decrement if pointer is given is constant time for key decrement and repeated n times, n plus n square plus n. Then overall time complexity of algorithm, okay, time complexity of algorithm by using unsorted array, time complexity of algorithm by using unsorted array is become order of n square, theta of n square. Then if you go for min heap, okay, so one insertion is log n time, n insertion is n log n time. Because keys inserted one after other, it's not like we build the min heap in bottom up approach. Okay, we need to build the min heap in by inserting one key. So that means n log n time. So delete min heap, one delete min cost required log n time, n times delete min is n log n. Okay, one key decrement is log n time, and repeated n key decrements n log n. The overall cost of this algorithm is become theta of, okay, n log n. Means compared to unsorted array, min heap is less cost. Okay, if you go for sorted array, see first insertion not first element already in the sorted order, like a insertion sort because we are inserting one by one, like the array is become inserted as like insertion sort. That means it required n square time for n insertions, okay, because of the sorted order. Okay, one delete min array shifting is required, order of n time for one delete min, okay, repeated n times is become n square. Key decrement is also required array shift operations. Okay, so n times key decrement is become n square time. Overall cost of algorithm become n square. Then sorted double linked list. So the insertion one after other is required n square time for n insertions, and delete min is constant time for one delete min because it is first element is the minimum element, n deletions is order of n time. The key decrement is also because of the sorted double linked list, one key decrement is n time, so n key decrements is become n square. So then overall time complexity is become n square. So then min heap is better, so min heap is less time complexity. So answer to this question is option B. So all are given option A. Okay, so in case that's why min heap is better for the priority queue operation. All these are priority queue operations basically, delete min, key decrement, insertion, priority queue operations. For priority queue operation min heap is best, right? Is this cleared? So this form of question used to ask. So please let me know any doubt over any of these complexities. So time complexity required for various, okay, input data structure for various operation. So practice it properly. DBC, right? So remaining A, C, unsorted array, sorted double linked list, then algorithm cost becoming n square. If you go for min heap, algorithm cost is n log n. Okay, please post your comment if any doubt over here. So next question. So both are questions related to time complexity. This is also known question and maybe 1-2 times PYQ also given. Okay, in PYQ also is given, but it is very important model, you need to recollect. Okay, just for revision purpose I gave this question. It is not a completely new question. So what is time complexity of the Prim's algorithm? Direct time complexity. Time complexity of Prim's algorithm. Okay, to construct MST by using priority queue is sorted linked list. Priority queue is sorted linked list. Okay, and graph represented in adjacency matrix form. Graph represented in adjacency matrix form. Okay, in a simple undirected weighted graph of n vertices and e edges. Okay, so the same question for the next one also. Prim's algorithm only. Time complexity of Prim's algorithm. Okay, the priority queue is unsorted array now. The priority queue is unsorted array now, and the graph represented adjacency matrix form. Graph represented adjacency matrix form. Okay, so what is time complexity of these two algorithms? Time complexity of Prim's algorithm by using priority queue for greedy selection is sorted linked list. For next question, priority queue is unsorted array. So for previous question there are some doubts are there. There are some doubts I am just reading. Okay, so one doubt. So see, for sorted array key decrement, for sorted array what he is saying that, so bind such. So for sorted array, if you want to find the key, if you want to perform the insertion, you can find the position in order of log n time, but to insert element in correct position, array shifts are not reduces. Okay, array shifts are required. Okay, n array shifts for one insertion, the array shifts are not reduces. Okay, n array shifts required worst case, and n are order of n per insertion. That's why overall it become order of n square time. Okay, is the one question. So comparisons reduces if you go for binary search, but array shifts are not reduces. So key decrement in min heap. Okay, so is the other doubt. So key decrement, if pointer is given, key decrement is simply equivalent to insert function, just okay, shift the keys, shift the parent keys to down. Okay, log n key decrement is required, log n time for one key decrement, is required, log n time for min heap. Okay, so repeated n times, so n log n time. So I think these are the two doubts is given, right. Now see, for this Prim's algorithm or distress algorithm, two algorithms are exactly same time complexities, Prim's and distress algorithm. Okay, so distress algorithm for computing single source shortest path, distress algorithm for single source shortest path. Okay, or Prim's algorithm for constructing MST, Prim's algorithm for construction of MST, minimal spanning tree. Both these algorithms same procedure for time complexity operation. So time complexity of distress algorithm as well as Prim's algorithm. So mainly three important things. So n times delete mean required from the priority queue, n times delete mean from priority queue is one important cost, and we need to find adjacency of all vertices. Okay, adjacency of all vertices. Okay, we need to find the adjacency of all vertices. And third cost, so sum of degrees means order of e times. Sum of degrees is order of e times key decrement. Okay, order of e times key decrement. So these are the main operations required. These are the main operations required for distress algorithm as well as Prim's algorithm. Distress algorithm for single source shortest path, Prim's algorithm for so construction of MST. So these are the three main operations required to compute the single source shortest path by using distress or construction of MST by using Prim's. Okay. Now the first question, this 13th question. Okay, this 13th question. Okay, this first question. So the priority queue is sorted linked list. If priority queue is sorted linked list, okay, sorted linked list, and the graph is adjacency matrix graph. Okay, adjacency matrix only na, yeah, adjacency matrix graph. Okay, so is the data structures. See, n sorted linked list. Okay, one delete mean required n time, one delete mean required n time, repeats n delete means. So the adjacency of all vertices, sorry, one delete mean required constant time, sorted na, sorted linked list, one delete mean required constant time and repeated n times. Finding adjacency of all vertices because of adjacency matrix, order of n square time. Okay, then one key decrement from the sorted linked list, one key decrement required order of n time and it is repeated order of e times. Okay, order of e times, then leading term is become e multiply with n, order of e multiply with n is the time complexity, worst case become n power 4. Okay, so the first question answer is option C. Then this 14th question. Okay, this 14th question. So unsorted array, okay, unsorted array is used, then again adjacency matrix is used, adjacency matrix representation is used. These are the three main operations which are affected for time complexity because of unsorted array. So delete mean required more time, order of n time for one delete mean and repeated n times become n square. So time required to find adjacency of all vertices is order of n square time and the order of e times key decrement. So key decrement required constant time because of unsorted array is e. So worst case edges also n square. So overall time complexity is become order of n square. Overall time complexity of algorithm is become order of n square, option A. So these are I think you all known question only, nothing, not a new question, but this is important thing. Time complexity of the single source shortest path by using distress or Prim's algorithm minimal cost spanning tree to compute time complexity. These are the three main operations. Okay, in overall throughout the algorithm of distress and Prim's, okay, these are the three operations performed. Okay, main cost, remaining build, min, heap and other small costs are there, that is not exceeds the these value, sum of these three value. Mainly time required for, okay, so n times delete min and time required to find adjacency of all vertices and order of e times key decrement operation time complexity. Sum of these three is become overall time complexity. Okay. Right. Right. Okay. So try this question. Okay. So think and answer properly. Properly think and answer. Okay. So similar question given, but not the same question. Okay. Because similar question given 3-4 times in the exam. A complete binary tree, complete binary. Okay. Max heap. Okay. Max heap related question. Okay. Each integer 1 to 2047 exactly once. Each integer exactly once. Okay. So the depth of node in the heap is the length of the path from root node to the heap. Okay, heap node, that node, the depth you already know. Okay, root depth is considered as 0. Okay, root depth is considered as 0. The difference between maximum and minimum depth at which integer 511 can appear. 511 can be how much maximum depth and 511 can be how much minimum depth. The difference we need to know. Okay, difference between the key 511, how much minimum and maximum depth. So binary heaps, priority queue questions, these are very important. So PDF of this session. Okay, so PDF of this session, if required, then just message me in Telegram or in WhatsApp. Okay, so we'll share personally. Only for algo. So what is this? The element 511 can be in minimum what depth and maximum what depth. The difference. Right. So minimum and maximum depth of the keys. So total okay, total 2047 means height 10. Okay, so depth 0 to 10. Okay, depth 0 to 10. So that means total number of nodes are 2012 to 2047. Okay, that means total height of the tree. The height of the tree is 10 height. Okay, so height is 10. Depth is also 10. Right? Now, see element 511 maximum can be at the leaf level. Okay, so maximum can be at the leaf level. It means so 511 can be in one of the leaf node. One of the leaf node can be 511 is one possibility. Then depth is 10. Okay, maximum depth of key 511 is 10 at the leaf level. Then what can be the minimum depth? Minimum depth of key 511 is minimum how much depth it can consist. Okay. See, this is the max heap. So 2047 is the root. 2047 in the root. Okay. See, the element is 511. Okay, element is 511. It means that 510 keys is minimum than the 511. 510 keys is minimum than the 511. Okay, so because of that it can't be come to the level 1, depth 1. Okay, 511 not possible to come to depth 1 because so this subtree of depth, like assume that this node height is 10 and this node height is 9. Okay, this node height is 8. So this node height is 8. So height 8 means 2 power 8 plus 1 means a number of nodes of the height h. Okay, number of nodes of height h. Okay, of height h. Okay, height h complete binary tree. Okay, so complete binary tree, number of nodes of height h, 2 power h plus 1 minus 1. Okay, that means this subtree is become 2 power 8 plus 1. Okay, 2 power 8 plus 1. Okay, so means 2 power 9. 2 power 9, 2 power h plus 1 minus 1. So 2 power 9 minus 1 is becomes 2. Okay, 255 na. So sorry, 511. So it become 511. So this subtree has this subtree has 511 keys and this subtree also should be 511 keys. Okay, 511 plus 511. Okay, 511 plus 511. Okay, so already so 1022 keys. 1022 keys. Okay, this key should be greater than 1022 keys. This key should be greater than 1022 keys. So worst case it can be 1023. Worst case it can be 1023. Okay, so the less than 1023 not possible here. Less than 1023 not possible here. It means that 511 can't be in the depth 1. 511 can't be in the depth 1. Now if you come to this depth, next level, okay, one of this node. Okay, if you go to this one of this node, let's assume that let's consider this node. If you take this node height is 8. This node height is 8. Okay, this subtree. Okay, this subtree 2 power 8 plus 1 nodes. Okay, so 2 power 8 plus 1 minus 1. Okay, that means 2 power so this subtree height is become 7. Okay, 2 power this subtree consists the height of this subtree is 7, right? So 2 power 8, 2 power 7 plus 1, 2 power 7 plus 1 minus 1 is becomes 255 nodes. Okay, so this subtree should have 255 keys. This subtree should have 255 keys. 255 keys in this subtree and 255 keys in the second subtree. So 510 keys. Then 511 can be here. 511 is possible to here. That means this is the case 2. 511 minimum depth is second level. Minimum depth is second level, maximum depth is 10th level. So the second level or 10th level, the difference is 10 minus 2. 10 minus 2, difference is 8 levels. So answer to this question is, so numerical value 8, right? Yeah, maximum depth is at the leaf node. This one, maximum depth is at the leaf node. Okay, this depth is 10, this depth is 10 because root depth is considered as 0. Okay, depth of root node is 0. So this depth is 10. Okay, so maximum depth of 511 is leaf level. Okay, this is the maximum depth. Minimum depth is this level. This is the minimum depth. Right? So minimum depth of 1023 is second level. Minimum depth of 1023 is second level because for 1023 there are 1022 childs, 1022 descendants. 1022 descendants should be smaller than 1023, then only it is max heap. So then similarly 511 minimum depth should be at the third level, not possible to come to the second level. Okay, because 511 means the key 511 means only 510 is minimum. 510 is less than 511. 510 is less than 511 means this subtree is 255 keys. This subtree is 255 keys. Already 510 keys on the descendants. Then 511 can be at the height 8. Height 8 or we can say depth 2. Okay. So two cases I explained here. So this case is about the maximum depth. Okay, this case is about the maximum depth and this case is about the minimum depth. What will be the answer if they ask min heap? So min heap min heap in the sense, so you need to see the min heap. So anyhow 511 can't be at the root level, 511 can't be at the root level. So for min heap, okay, for min heap just similar way, you just recalculate one more time. So instead of looking for how many smaller elements should be descendant. If it is a min heap, how many bigger elements than 511? So compared to 511, how many bigger elements are there out of 2047? 2047 minus 511. So those many elements should be in the descendant side. Those many elements should be in the descendant side. Based on that, you need to see the minimum depth. Okay. So similar way, you can just try to do the calculation. Easy question only. Is this fine? Okay. So 2047 minus 511. Okay. So means see how many more keys, how many keys are, okay, so which are bigger than 511. Okay. So that is the key point for the min heap. So if it is 1023, if it is 1023, so maximum depth still it can be at the leaf level, maximum depth still it can be at the leaf level, minimum depth is second level, okay, sorry, depth 1. So 10 minus 1 is become 9, right. Now let us see the one more question. So consider an array, it is also similar model, given 3 times the same model question in the exam, same question in the exam, I just change the numerical value to 9. So if it is 9 distinct elements, if it is 9 distinct elements, okay, so how many possible max heaps, okay, what are the number of max heap orders, okay, total number of ordering possibles, total number of ordering possibles, okay, possible for max heap, okay, to represent max heap, okay. So just for revision purpose I used this question again. So for n equal to 7, 2 times in the PYQ, okay, and 3-4 times in the DRDO ISRO exams, okay, so repeatedly given the same model question, so just recollect it once. So so see this one, assume that number of keys and number of possible min heap orders, min heap or max heap, anything, both binary heap, number of possible binary heap orders, okay. So if it is one key, okay, so complete binary tree of one node is okay, one binary heap only, okay. even for two keys, minimum key should be the parent, so the one more key should be the descendant. So still it is one binary heap. Okay, if it is three keys, assume that keys are 1 2 3. Okay, assume that keys are 1 2. Okay, three keys, complete binary tree, binary heap is a complete binary tree. So complete binary tree of three nodes, so minimum key is become root, and among two keys, okay, you can choose any one for this left subtree. Okay, that is 2C1 choices. Okay, so those one key, if you have selected one key, among that one key is one possibility of min heap only for this left subtree. Okay, for this right subtree, remaining one key is only left, one key is only left means one possible selection. Okay, then overall it is two min heaps only, binary heaps only. Okay, if you take four keys, so I'm just explaining for all different possibilities also, not only for this question. Okay, just to answer this question perfectly without any confusion. Okay, complete binary tree of four nodes, out of that one key is go to the root node, and remaining, okay, remaining three keys are left, out of three keys you can choose any two keys here, that is 3C2 ways. Okay, 3C2 ways, and among those two keys, one min heap only, for two keys one min heap only, and remaining one key only left, one key means one min heap only. Okay, 3C means total possible min heaps are 3. Okay, so like this you can calculate. So now the question is about the 9 keys. Okay, if 9 keys in the list, so out of 9 keys, so complete binary tree of 9 nodes, because binary heaps is complete binary tree of 9 nodes. Out of 9 nodes, okay, one key is become root, minimum key is become root. Okay, remaining 8 keys are there. So among 8 keys, you can choose any 5 keys for the left subtree. Okay, you can choose any 5 keys for the left subtree, and among those 5 keys, okay, among those 5 keys, 4 keys we already written, okay, 5 keys. So let's assume that 5 keys we are selected here. Okay, whatever 5 keys we are selected, out of 5 keys, one key is become parent root. Okay, remaining 4 keys, you need to select 3 keys for the left subtree. So out of 5 keys, one key is become parent. So remaining 4 keys, okay, so 4 keys, 3 keys has to be selected, 4C3. Okay, among those 3 keys, among those 3 selected keys, okay, so this 5 keys for the left subtree. Okay, this 5 keys for this left subtree. Okay, and for 3 keys required here. So among those 3 keys, one key is become root. Okay, and so this 3 keys we know, two binary heaps. Okay, and after that 5 keys plus 1 key, 6 keys are over, only 3 keys are left, 3 keys, two binary heaps possible. Okay, so so this is the number of binary heaps for left subtree. Okay, this is the number of binary heaps for left subtree, and 3 keys for the right subtree. Okay, 3 keys for the right subtree. Among these 3 keys, okay, 2 binary heaps possible. So do the calculation. Okay, so 4 multiplied with 2, 8 multiplied with 8C5 multiplied with 2 for the right subtree. So the answer to this question is, so yeah, so 896 here. So 896. Path. got it. Right. So, similarly means n equal to 5 is this much. Okay, so if it is a 5 keys total 8 min heaps, 6 keys 7 keys also practice it. So this is repeatedly used to ask this binary heap question. Okay, so every year one 2-mark question or two 2-mark question used to ask from the binary heaps. That's why trying to recollect the concept of binary heap. Now so simple question only, this is very simple question. Which of the following statement is are true? Okay, two statements are given. Okay, a sorted array is a min heap, true or false? So array represented in C, okay, for storing n elements, okay, n elements binary heap. Okay, so the leaves are the nodes indexed by. Okay, what are the indexes of the leaf nodes? Okay, n by 2 floor plus 1, n by 2 floor plus 2 up to so on n minus 1. These are the leaf node indexes. Is correct or wrong? Okay. Okay, Srijit says A, DGS answered A. Srijit changes answers from A to C. Okay, array represented in C, it means that the root node index starts from 0. Root node index of the binary heap starts from 0. Okay, so just recollect it properly. This kind of scenario is also possible. Okay, assume there is one array A. Okay, so for example, not in the C language, generally I'm writing a of 1, a of 2, a of 3, a of 4, okay, up to so on a of n elements, and we know that. Okay, so complete binary tree are binary heaps, okay, of n nodes, okay, number of leaf nodes are, okay, okay, so exactly n by 2 seal, leaf nodes, number of internal nodes, is exactly n by 2 floor. Okay, is the complete binary tree of n nodes. Okay, complete binary tree of n nodes. number of leaf nodes and number of internal nodes, n by 2 seal and n by 2 floor. Okay. Now, if array index starts from 1, n by 2 leaf nodes, so n by 2 floor internal node starts from a of 1. If array starts from 1, then a of 1 to a of n by 2 floor, a of 1 to a of n by 2 floor, till this it is become internal nodes, because total n by 2 nodes, n by 2 floor, count is this much. This is the count. If index starts from 1 till that is an internal node indexes. Okay. The next node is become the leaf node. The next node onwards becomes the leaf node. So the leaf node is become, so n by 2 floor plus 1, n by 2 floor plus 1 to n is become the leaf nodes. Okay, leaf node indexes are starts from n by 2 floor plus 1 to n, right? Now, but he is saying that the array is represented in C language. Okay, so according to the array form of the C language. Okay, so array index, this is the generally we use in the algo, but because of the array defined by the C language. Okay, so index starts from 0. Okay, index starts from 0, that means last key index is become n minus 1. Now, n by 2 in n by 2 floor internal nodes and index starts from 0, that means the internal node indexes are becomes, till n by 2 floor minus 1, till n by 2 floor minus 1, these are become an internal nodes now. Okay. If these are internal nodes, the next node is become, next node onwards the leaf node. Okay, then leaf node index is become n by 2 floor. Okay, so minus 1. Okay, next index is n by 2 floor, n by 2 floor plus 1 up to so on n minus 1. These are become leaf nodes. Okay, so this second statement is false. Okay, second statement is false. Okay, so because this second statement is correct if array index starts from 1, if array index starts from 0, the first leaf node starts from n by 2 floor and last leaf node is n minus 1. Okay, so n by 2 floor plus 1 is not the first leaf node. Okay, so because this is the array index is considered for this one. So count of leaf nodes is no change. Count of leaf nodes, okay, is n by 2 seal and count of internal nodes n by 2 floor. Okay, so that means only first statement is correct. Anyhow, sorted array is min heap, that is known to you, no confusion for first one. Yes, A only correct na. So small observation, this kind of small silly mistakes. Okay, so you all know that how many internal nodes and how many leaf nodes and all. Okay, but just read the question carefully and so answer it properly. Okay, so Srijit, you answered first correctly, then after that you change the answer, right? So complete binary tree of n nodes, n by 2 seal is the number of leaf nodes, number of internal nodes are n by 2 floor, and if array index starts from 1 to n by 2 floor is become internal nodes, next onwards leaf nodes. If array index starts from 0 to n by 2 floor minus 1 is become internal nodes, the next node is become index of the leaf node. Right? Solve this question. Okay, let P is the shortest path from some vertex S to some other vertex T. Okay, P shortest path from some vertex S to some vertex T. Okay, in a directed graph. Okay, if the weight of each edge in graph increase by constant c, weight is increases by some constant c, okay, then also p will be the shortest path from s to c, s to t, true or false. Okay, then if weighted directed graph G is known to have no shortest path longer than p edges. Shortest path doesn't have more than p edges. Okay, then it is sufficient to run Bellman-Ford for p passes. True or false? Okay, to compute the shortest path of the source. Okay, a graph where all edge weights are distinct can have more than one shortest path between two vertices. Okay, distinct edge weights. Okay, so then multiplying all edge weights by positive number, okay, will not change the cost of MST. If you multiply, so all edges by some positive number, okay, MST is not changes or MST changes. True or false? So this kind of graph questions very important. This kind of graph questions, okay, so important for examination. So try properly. Think and answer and cross verify. No need to hurry. Take time and read the statement. Okay, right. So see this one. P is the shortest path from S to some vertex T. So shortest path from S to T. Okay, shortest path from S to T. Okay, is some that path is P. P is the path. Okay, then if the weight of each edge increased by some constant, okay, so weight of each edge increased by some constant, so assume that this P, this shortest path, okay, let's say some x edges, that means this x edges, the C is added, x edges C is added, that it means it becomes x multiply with C, the path cost is become x multiply with C. Some other path can have, okay, less edges, slightly bigger than P, slightly bigger than cost of P, but less edges, because of adding C, okay, for less edges overall cost can be reduces. Okay, so for example, Okay, for example, this is the one graph. This is the one graph, and this one directed graph is given, and let us say this edge is 10 and this edge is 15 and this edge is 20. Okay, so the path cost is become how much? So 25 and 25 plus 20, 25 plus 20 is 45 is the path cost. Let's say there is other path which has less edges. Okay, so 20 and this cost is assume, let's assume this cost is slightly bigger than 26, 26 plus 20. So now this path consists two edges and the sum of edge weights are 46, and this path consists three edges, sum of edge weights are 45. Okay, then obviously this 45 is the minimal cost. This is the shortest path which involved three edges. Now if you add some constant edge weight to all the edges, okay, so constant edge weight is added to the all edges. Let's say every edge increased some plus 10 or plus 5. If every edge is increased plus 5 or plus 10, now the previous path 15 added, but this other path 10 added because of two edges only involved. Now shortest path is changes. Now this is become shortest path. Okay, this is becomes the shortest path. Okay, so shortest path need not be the same like before. Okay, that means first statement is false. Shortest path guarantee same, going to be same is not true. Okay, so may changes, shortest path is may changes. It depends on the other path having less edges or not. No other path having less than 3 edges, no other path having less than 3 edges. Okay, then the shortest path is remain same. Okay, so now then if the weighted graph, okay, weighted graph G known to have no shortest path longer than p edges, maximum p edges in the shortest path. If maximum p edges in the shortest path, okay, so p passes of Bellman-Ford algorithm is required. Okay, so if okay, shortest path from source to other vertices, okay, if shortest path from source to other vertices has at most p edges. Okay, no path having more than no shortest path from source to other vertices more than p edges, then the we need to apply edge relaxation for all edges p iterations, guaranteed you will get the shortest path. Okay, so that means Bellman-Ford algorithm okay, p iterations required. Okay, p iterations required, so write as a note. So take this is like a note. Okay, so that's the reason Bellman-Ford algorithm in generally for single source shortest path, Bellman-Ford algorithm, okay, we repeat n minus 1 iterations, because for any graph shortest path is not exceed more than n minus 1 edges. So at most the path can consist, shortest path can consist at most n minus 1 edges. Okay, if shortest path consists at most n minus 1 edges, then Bellman-Ford algorithm required n minus 1 iterations of edge relaxation. Okay, that is the reason Bellman-Ford algorithm apply edge relaxation for all edges n minus 1 times. Okay, so this second statement is true. The second statement is true. Then third one. So a graph where all edge weights are distinct can have more than one shortest path, that's true only. Okay, so assume if this is also 25, so this path is also 45 and this path is also can become 45 if you take this edge is 25. So that is true. So more than one shortest path can possible even edge weights are distinct. Okay, if distinct edge weights, only unique MST possible but not unique shortest path. Okay, shortest path may not unique, but MSTs are unique for distinct edge weights. So multiplying all edge weights by positive number, okay, under assumption edge weights also positive. Okay, multiplying all edge weights are by positive number. If you multiply by same positive number for all edges or add by same positive number for all edges, okay, the shortest path may changes, but MST not changes. Okay, because if you take the MST, okay, if you take this MST, so this first mean cost edge, second mean cost edge, third mean cost edge, these three edges are in MST, and after adding 5 or multiplying 5, then still MST is same. Okay, MST not changes, shortest path is only changes. So it is also true statement. So answer to this question is BCD. Okay, answer is BCD. Right, just so the 2-3 notes are there. So how Bellman-Ford behaves. Bellman-Ford we apply edge relaxation for all edges n-1 times, because shortest path from source to other vertex can have at most n-1 edges. Okay, so if shortest path consists at most p edges known to you, okay, then Bellman-Ford algorithm p iterations only required. Okay, then if every edge added by some positive constant or multiplied by some positive constant edge weight, if every edge weight added by some positive constant or multiplied by some positive constant, okay, shortest path may not be same, before and after, but MST is going to be same, minimal spanning tree is same before and after. Okay, so the MST not going to be changes, but shortest path may going to be changes. Okay, because shortest path so is also depends on how many edges involved for the source to destination. Okay. Okay, yeah, so the first one is about the, see the first option and fourth option both are same, means both are adding constant or multiplying constant, but one for the shortest path, other for the spanning tree. So adding constant or multiplying constant, spanning mean MST not changes, but adding constant to the every edge or multiplying constant to the every edge, shortest path may be changes. Okay. MST not changed. Okay, right, I think it is cleared. Okay. Any doubt on this? So 4 important statements are there in the same question. Okay, very much important statements. How Bellman-Ford algorithm behaves. Okay, and as well as if every path is increases by constant edge weight for all edges, decreases, okay, sorry, multiply, so increases by some positive constant or multiply by some positive constant, shortest path may changes, okay, before and after, but MST not changes, because the edge, the min cost edge relative order is again same thing only na previously. So first minimum is 10, after adding 5 also first minimum is the same edge only. Okay, relatively the edge cost relatively the increasing by everyone. Okay, the min cost edge, second min cost edge, and these things are not going to be changes because of multiplication of constant to all edges are okay. So adding constant to all edges, so MST, that's why not going to be changes, right. Next, So try this question, is about the graph traversal. Okay. So I'm just reading the question and I'll give you time for analysis. Consider the vertex A to A and B, vertex A and B that simultaneously on the function. Okay, that means A and B both vertices simultaneously on the stack. Okay, same point of time execution of DFS call. Okay, in that scenario, okay, for directed graph or undirected graph is not mentioned. Okay, so okay, first statement, if there exists directed path from S to A and directed path from S to B, it means that, so from source you applied the DFS in stack. Okay, stack is used for the DFS call. So stack, and you are started from the source. Okay, from source the stack is started, okay, of the DFS call, and one of the vertex A visited, okay, one other vertex B visited. By the time we are relaxing by the time B is added to the stack, A is not removed. That means the A is not completed. A and B both are there in the stack simultaneously. Both are there in the stack and simultaneously, not like after pop the A and B is inserted. Okay, both are there in simultaneously A and B. So in this scenario, if exist, okay, so there must be path from S to A and directed path from S to B. Okay, there exist both a directed path from A to B and directed path from B to A. Okay, and third one, there is no directed path from A to B. If there is no directed path from A to B, there exists directed path from B to A. Right. So if both A and B are in the stack, both A and B are in the stack, okay, and S is a source. Okay, S is a source means first entry added into the stack is S. Okay, so see, so from S the edge relaxation means say, so S is explode, S adjacent is someone, so other adjacent like that. After that A is explode, A begins. Okay, that means there must be path from S to A also, and there must be path from S to B also. Okay, so then only A and B along with S in the stack. The first statement is true. The first statement is true. Okay, so it is something like this. Okay, so the S is started, S is added into the DFS spanning tree should be like this. DFS spanning tree should be like this. Okay, S is added, next vertex, some vertex visited, some adjacent vertex visited. Okay, so still assume A is visited one of this position, and after that, okay, after that, so see, before pop the A, B visited. That means A exploration not ended, A exploration not finishes. Before that, B exploration begins. B exploration begins. That means there should be path from S to A also. There is a path from S to A also, and there is a path from S to B also. Okay, both are correct. Okay, so now the second one, there exists a path from A to B and B to A, both may not be correct. Okay, so there may be a path from A to B, or there may be a path from B to A, depends on who added first. Okay, if A added first and after that before popping A, then B added, before popping A and B added in the DFS traversal, then there is a path from A to B. There is a path from A to B, and there may not be path from B to A. There may not be a path from B to A. Okay, so is also true statement. Okay, so but he is saying that A to B path also should be there and B to A path also should be there, may not have both the paths. Okay, the second statement is false. Okay, third statement, if there is no path from A to B, if there is no path from A to B, there is no path from A to B, okay, it means that, so A, B both are simultaneously in the stack, A, B both are simultaneously in the stack, no path from A to B, it means that B explored first, and before completion of B exploration, then A explored. Okay, this is the scenario. Then only A and B both are in the stack and there is no path from A to B. If there is no path from A to B, obviously there should be path from B to A. Okay, there should be path from B to A is also true statement. Okay, so that's why S1 and S2 both are correct. This question is the one logic, the based on the same logic we use the means say strongly connected components. What we do for the strongly connected components? Okay, so we call DFS and store vertex exploration completion order in the stack, and we compute the transpose graph and again traverse by using top of the stack. Because of traversing given graph, you will get the path from A to B, and because of traversing transpose graph, you are checking path from B to A. Okay, that's what we call it as a strongly connected component. Same logic is applicable for computing the strongly connected component of the problem also. Okay, so hope you cleared this one. S1 and S3 is correct, right? Okay, last question. Find the total possible number of back edges. Okay, number of back edges. Number of back edges from source is A. Okay, starts from A. A is a source vertex. Okay, take the graph and how many back edges? Yeah, Anushka here, right. Okay, so just call that DFS. So A adjacent. Okay, assume A adjacent B visited and B adjacent. Okay, let's say F visited, F adjacent C visited, and C adjacent D visited, and D adjacent E visited. Okay, so it is become skew tree because okay, there is a Hamiltonian path for the Hamiltonian cycle in the graph. If there is a Hamiltonian cycle in the graph, okay, if there is a Hamiltonian cycle in the graph, okay, path in the graph, then DFS is become skew tree. DFS is become skew tree. Okay, so the DFS tree is become skew tree here. Now see what are the remaining edges of the graph. Okay, so the remaining edges are, so D to A is also back edge and C to A is also back edge, and so E to F is also back edge and E to C is also back edge and E to B is also back edge. So remaining all 5 edges are the back edges. Right? Any doubt on this? So from last 2-3 years, algorithm questions are okay, so easy questions only, not complicated questions. Don't fear like the questions are difficult in exam, nothing like that. Read the statement clearly and so the try to understand what exactly he is giving and read options also before start solving the problem. Okay, so it's not difficult questions. Okay, so whatever the questions we are discussed, this 20 questions is almost more than 15 different areas. Okay, so 2-3 questions, 2 questions, same concept of the insertion sort and selection sort, like that 1-2 places same concept, 2 questions are given. So almost more than 15 different areas I try to cover with these 20 questions. Okay, so please tell me important topics. Yes, I will tell you important topics at 5 more minutes. I will close the session. It has become long. So before going to the important questions, okay, just go through it once. Just go through it once, either now or after during the recorded session. But please go through it once. Okay, in 2024 exam, there are 2 papers. Okay, paper 1 and paper 2. See, one question related to bubble sort logic, and so spanning tree count, and DFS, max heap, one more question, and reconciliation DFS. See how many are graph questions and tree questions. So DFS and max heap, and this also max heap, and again DFS and spanning tree question. Okay, so understand importance of the greedy algorithm onwards. Greedy algorithm onwards, like a shortest path algorithms, spanning tree algorithms, graph traversals, and shortest all pair shortest path algorithm of dynamic programming, and binary heaps. Okay, so those many questions almost means the second half of the algorithm, like a first half of the algorithm, like a fundamentals and greedy divide and conquer. So second half of the algorithm is giving so many more number of questions in last few years, and not only that paper, other paper also you can see it. Second paper given less number of questions, out of the three of them. So one is only reconciliation. So maximum subarray is 2 questions. Spanning tree question is given. How many spanning trees? How many minimal spanning tree? Again graph questions. Okay, is the 2024. These many are graph and tree questions. Binary heap onwards. Binary heaps. Okay, complete binary tree concept and tree representation, graph representation, and those things are more important. Okay, like even 2023 if you observe. Okay, so here okay, BFS one question, max heap one question, asymptotic notation is one question, again one more max heap insert and delete question. So binary heaps 2 questions in same paper. So here also binary heaps I think 2 questions na. So binary heap 2 questions in same paper. So then here MST is there, second paper binary heap question is not there I think so. Okay, so the binary heaps is every time they are used to ask, that is why today I covered almost 6-7 binary heap questions. Okay, so loops, time complexity, asymptotic notations, that is one thing. Then in 2022 paper again asymptotic notation question, and one is on BST. Complete binary tree form of the BST one question is there, you can just a good question, just practice it properly. And again, so again graph edges, okay, MST question, and again one more graph question and spanning tree question. Okay, so then this is also like a complete binary tree form, it is also like a complete binary tree form. So see, so out of 1 2 3 4 5 6 7, out of 7, okay, 7 or 8, okay, 7 out of 7. So 5 questions are from the binary heaps, okay, and so greedy graph algorithms and graph traversal algorithms and the shortest path algorithms. Okay, so maximum second half of the algorithm revise more and more number of times. Okay, so that doesn't mean that first half of the algorithm is ignored, don't ignore it, but that's a standard model question, you will able to deal it. Divide and conquer questions are a standard model, you will easily able to handle. Okay, so more practice required for the second half of the part of algorithm. Okay, so again if you go for 2021 second set, one more set, 2 sets are there. Okay, one more set. Okay, min max algorithm, one of the question, notation one question. Okay, so minimum comparisons of the, so BST, okay, one time complexity question and MST question, okay, graph traversal question. So here the distributed equally, first of all, so given notation and reconciliation is for fundamental side, and minimum comparisons to sort. So sorting algorithm question is there, and min max algorithm, divide and conquer. So equally distributed, 3 questions are from the second half and 3 questions are from the first half and 1 fundamental question. So equally given. Okay, so next in 2021 again MST question and binary heap question and 1 question for BST time complexity. Okay, graph traversal question. Okay, so and graph traversal and topological ordering 1 question. Say out of 1 2 3, okay, 4 5 6 7, out of 7, so 5 questions are from the graph and trees. Okay, so graph and trees, Huffman coding, reconciliation, master theorem. Okay, so Huffman coding also divide and conquer, it also comes under a second half. Okay, is also two-way optimal merging. Okay, reconciliation 1 question. Okay, see more questions are from the graph based questions. Then even 2020 if you observe. Okay, so then one reconciliation sorting question, MST question, and it's also tree form of the question, shortest path question, again one more question related to the tree, and binary heap and MST question. Okay, so except see, so the means say what happened whenever you open the algorithm, first 50% of algorithm if you revise, second 50% of algorithm don't, if you not give the good importance, okay, it may not correct strategy for the exam. See the history. Okay, almost 1, 2, 3, 4, 5, 6, 7, 8 out of 8 questions, and okay, so sorting one question, reconciliation one question. So more are trees and graphs only. Okay, so are you able to understand the importance of the second half of the paper? So similarly, you can see the 2019. Okay, it is again equally distributed, I think so. So quick sort, divide and conquer, and maximal subsequent sum, and so median. Now in this equally distributed MST, binary heap, and full binary tree, 3 okay, 3 questions first half and 3 questions second half of algorithm. And 2018 also, see the second half, matrix chain problem, dynamic programming, graph traversal, and for loop, and binary heap, and MST. Here also greedy and dynamic programming questions only more. It is also greedy method, it is also greedy dynamic programming question, and greedy method question. Okay, so graph traversal question and binary heap question. Okay, so almost graph and tree are 4 questions, one other greedy algorithm question, and one dynamic programming question, one fundamental question. Okay, so more probability 2018 onwards I seen, and before that there may be more questions in first half, because after introducing MSTs, okay, multiple selection questions as well as okay numerical questions, and the more graph based and tree based, these are more better for forming the MSQ question and all. Okay, so analyze properly, and the graph algorithms. So graph representation onwards, graph representation and shortest path algorithm, single source, Bellman-Ford, and as well as distress algorithm, as well as BFS for unweighted graph, and so spanning tree topic, and minimal spanning tree topic, and the all pair shortest path, Floyd Warshall's algorithm, as well as the graph traversal applications. Okay, so as well as the binary heap and complete binary tree related and binary heap questions. This area is more possibility of getting marks in examination compared to the remaining areas. Every area try to so revise once, but this graph and trees and these things are focus little more. Okay, focus little more. So this is all about the today's algorithm session. So thank you so much for all your support, all the 3 hours. All the very best, and we'll continue DBMS GTQ session in tomorrow's class. Thank you all. Have a great day.